Good morning, everybody. Welcome. We are going to be doing a quick hitter on the EVOX G3, very exciting piece of equipment that is coming out. I'd like to give a quick shout out to our sponsors, Gensco, your one-stop HVAC shop, and Columbia Manufacturing. So without further ado, I am Sean Regis, your FSR host, and we will get this slideshow going. All right, let's first talk about the warranty. Residential applications must be registered within 60 days of installation. 12-year parts on the compressor. Standard to the original purchaser is 5-year, 7-year on the compressor, and subsequent owners, if the house sells or whatnot, it does have a 5-year parts and compressor. Commercial applications, 1-year parts, 5-year compressor. Introduction and applications. Let's talk a little bit about this equipment. It is extremely low temp, great performance. Price point to performance is hard to be beat, okay? We've got on a 3-ton hyperheat, we've got 100% capacity at -4 degrees with a COP of up to 2.0. And continuous operation as low as -22 degrees. So that is fantastic in those cold climates like Idaho, Montana, Eastern Washington, Eastern Oregon. And also we only sell the hyperheat models, not the standard. So every piece of equipment that you purchase it from my, in Midea is the hyperheat version. And this is what we're offering, 2 to 5 ton. Everything, like I explained earlier, is extreme heat. We've got the MAUSEH air handler, the M01 outdoor unit, and we also have cased coils for your dual fuel air handler, existing air handler applications. And we can put strip heat in the air handler, 5 to 25 kW heat kit. Notice that our cased coil is 17.5 all the way up to 24 inches wide. The refrigerant we are using is 454B. All of our models are extreme heat. We have dual communication modes, RS-485 communication with the TL04 stat, or you can choose to go standard conventional 24-volt controls. And you can use any thermostat you want on this, okay? I do not recommend using 24-volt controls. I would prefer that everybody use the Midea TL04 stat, fully communicating, and all the equipment, the outdoor unit has a base pan heater installed. Other brands and manufacturers, that is an accessory that you would have to install yourself. This comes pre-installed. We have hypergraph coated coils, and we have every one of our units is a heat pump. If you want to turn this heat pump into a straight AC, which is a fantastic option for those homeowners or business owners, data rooms, whatnot, that just want AC, we merely hit one dip switch, and now that is not a heat pump. It is straight AC. Let's go over some of our models here. At Gensco, we are only carrying the 2-ton to 5-ton models. I know you see that the 18K is on there, and we do not offer that at this time. Notice we have basically 4 sizes: 35 by 13 by 26, nice low profile; 37 by 16 by 32; 38 by 16 by 38 for the 36 and 48K models. And you'll notice that the 5-ton is a double stack 2-fan, 37, 16 by 52. Very nice low profile on all of this equipment. You will notice that we have a unique color description here, which is matching and blending in real nice to the houses for modern paint schemes. Here's a look at the performance on this equipment, okay? If you notice, the 3-ton model is at -4 degrees, is still producing 37,200 BTUs at -4. This equipment is big, big, big performance, okay? Also, you will notice on the 2-ton model, you'll notice this gradual dip starting at 47 degrees, dropping down to 17 degrees. This is actually inaccurate. This curve is actually drooping across this way, okay? So don't let the 2-ton model distract you here. This is a typo, basically, okay? And notice clear down at -13 degrees, we are still producing 36,000 BTUs on the 3-ton model. On the 5-ton model, we are still producing 44,000 BTUs. Big performance. This is one of the most efficient air handlers on the market, okay, with innovative indoor unit structure. The air handler is a block and lock design. It is a 2-piece air handler that you put together. It just simply stacks and locks together. SEER rating up to 19, our EER2 up to 12.5, HSPF2 10.8, and our COP at 5 degrees is 2.14. We have a very innovative M-shaped coil in the air handler and a fully commutated indoor blower. What is fantastic about this equipment, specifically speaking, the air handler, it is dual voltage, okay? It is 115 or 208, 230 volt, auto recognizing. The only time that you would actually need to land 208, 230 to this air handler is if you chose to install strip heat. If you wanted to replace just a standard furnace, you could do so without adding in strip heat. Just land your 115 volts. And the reason why we don't technically need to have strip heat in here is because when our unit goes into defrost, we have anti-cold blow technology. So think mini split. When this unit goes into defrost, the indoor blower shuts down. Then when that unit comes out of defrost, the indoor blower will not start spinning until the coil sensor senses between 79 and 81 degrees, our anti-cold blow. 115 to 208, 230 volt, you get a pick. It's an all-in-one package. Easy conversion to different required voltages, eliminating the hassle of rewiring. Like I said, the only time you need to land 208, 230 is if you're using strip heat. Flexible, adjustable, constant CFM. Customize airflow to maximize comfort. You have the ability to go low, medium, high, or turbo right from the TL04 stat. The MASU air handler special features, the dual voltage like we talked about, dual communication and auto detection mode. This equipment will auto detect if you're running a 24 volt conventional stat or the RS, well, we call it the TL04 Midea thermostat. New block and lock design, better airflow with constant 2.0 plus adjustable. Full airflow, this is important, guys. Full airflow up to 1.2 inches of total external static. That is very important because we know we have a lot of houses out there that have kind of crummy ductwork, okay? We get into some static pressure issues, and certain blowers don't like it and will go into blower faults, too much static. This will overcome that, and our high efficiency aluminum M coil. Smart humidity control built in. This is really cool. It will maintain 40 to 60% relative humidity on its own. So it's going to bring down that blower speed as needed to pick up more latent humidity. New air handler, an IAQ block and lock filter rack. This filter is a part of the air handler. It is not an accessory at this time. It comes with the equipment and built-in mitigation control. No installing a mitigation control board. It's already built in. Here is a look at our lock and block air filter. We can go from 1 inch up to 4 inches of filters. We can use MERV 13s. Standard industrial size filters. It has a magnetic door that just pops on and pops off for easy installation of that filter. Now, we were talking about our super easy modular design where the air handler is in 2 pieces. It makes it real nice to get up into that attic or in that crawl space in 2 pieces instead of collapsing or performing major surgery on that 1-piece air handler. This thing is so slick that one person can take 2 pieces up into the attic individually by themselves. And like I said, we can install heat kit into that Midea air handler. We are offering 5 to 25 kW. And this is a description on what size heat kits we can install in different air handlers. So you'll notice that our 36K model, we can't put a 3 kW in there, but we can go 5 to 20 kW. The only piece of equipment is the 5-ton unit that we can put a 25 kW heat kit in. Here is our look at our auxiliary heat kit, max circuit capacity, heater amps, internal circuit protection. There's our kilowatts and our part numbers. You're just merely going to let the counter know what kW heat kit you want, and they will round it up for you. Let's take a peek at our sizes of air handlers. Our 1.5 to 2 ton, specifically speaking 2 tons, since we're not carrying the 18K, is a beautiful 14.5 wide by 21 by 48. Real nice. Notice that we have the block and lock filter right there on the bottom. Our 2.5 to 3 ton models are 17.5 by 21 by 52. And our 4 to 5 ton models, 21 by 21 by 54 and 21 by 21 by 60. This is going to be real nice when you're doing those retros. This equipment's going to fit right in there real nice. Notice that we have 6 different positions that this equipment can be installed in. Upflow, downflow, horizontal left, horizontal right, and for our lowboy applications, right here. We can go down and up or up and down. And this great big plenum right here can be, well, you can manufacture it or you can just shoot Columbia Manufacturing a call and we will fab one up for you. Here's let's take a look at that TL041 stat. Might look pretty familiar to you. It is not an Ecobee. Okay, that is the Midea TL04 stat. This equipment is the air handler is Alexa, Google, ready to go Wi-Fi out of the box. You just need to have your homeowner download the Net Home Plus app and connect it to Wi-Fi, and you're ready to go. The Midea wired controller is a 2-wire non-polarity sensitive controller. Now let's talk about that real quick. 2 wires to the TL04 stat, 2 wires to the air handler, and 2 wires to the outdoor unit for easy installation. The stat, you can adjust the airflow and fan speed to low, medium, high, turbo, and auto. It will display errors on the screen, letting the homeowner know there might be a potential problem with their equipment. Comfort and energy savings, Wi-Fi accessibility right out of the box. You just on setup, click connect to Wi-Fi. It does like to be connected to 2.4 instead of 5. This thermostat will do OTAs, over the air updates, if available, if connected to Wi-Fi and the customer has the app downloaded. So I'm going to repeat that. OTAs are available to the stat if it is connected to Wi-Fi and the homeowner has the Net Home Plus app installed on the device. It is a touchscreen smart thermostat, sleek back black bezel with glass touchscreen, 4-inch color display, proximity sensor, Wi-Fi connectability, 7-day programmable, up to 8 events per day, and programmable fan settings. Communication with the EVOX G3, universal 24-volt, 2 heat, 2 cool heat pump control. So what that means is we can run fully communicating 2 wires to this TLO4 stat, or we can wire this stat 24-volt conventionally because it has RC, G, W, Y, O, everything on this stat. The terminals are right on the sub base. It does have the iCheck diagnosis, 3-stage auxiliary heater control. It will display weather and outdoor temperature provided by the Wi-Fi. Push button terminal block. Trim plate included that does have a bubble level on it to make sure that that thing is true plumbing level. And open ADR smart grid utility connection. Why use the Midea TLO4 stat in fully communicating mode? Well, it fully communicates with the system for max performance. It's only 2 wires. It's Wi-Fi ready to go out of the box with the Net Home Plus app. Different fan speed settings, high, medium, low, and turbo. 5 different modes. Schedule 8 events per day based on time, temperature, mode, and fan speed. Data checking mode. Unit error code display. And what is fantastic about the error code display is it is not just a general error code. This thermostat and equipment is so smart, it's actually going to tell you what the problem is. It's not going to have you go on a wild goose chase of what could be potentially wrong with the equipment. It's going to tell you what to go after. Heat pump and heat strip lockout setting coming soon via the OTA. Remember, the OTA is the over-the-air update. They must be connected to Wi-Fi and have the Net Home Plus app. So right now, we are not able to lock out the strip heat for those energy tax credits and whatnot, but that OTA is coming at the end of August this month. We are going to let everybody know when that OTA is available. So all your customers that are already installed, that if they're connected to the Net Home Plus and Wi-Fi, that update is automatically going to hit. So at the end of this month, we will be able to do those lockouts on that strip heat. And it does display the weather. Let's talk about our 2 wires. Fully communicating. Here we have our TLO4 stat. Notice I was telling you that we can wire this TLO4 stat conventional, 24-volt, or fully communicating. In this description you see here is just a standard 2-wire design. HA and HB go to HA-HB on the indoor board. And then S1, S2 travels from the indoor board all the way out to the outdoor board and land on S1, S2. So let's review that real quick. 2 wires, HA-HB to the indoor board, HA-HB, S1, S2, out to S1, S2, out at the outdoor board. We do not need to use 18-gauge stranded shielded wire. We can use standard 18-gauge solid wire. It is approved. We have had 0 communication issues using 18-gauge solid wire. But I do not want you using the old Cat5 cable that you would see on some of the Coleman equipment. Let's stay 18-gauge. Let's take a peek at the inside of our air handler. We have our 24 volt, our heater control wire. There's the breaker for our strip heat. And here is the air handler unit power terminal block right here. And behind this little door, we are able to look at our 7-segment display to view error codes or mode of operation. Here is our fan motor. This is a peek at our connections for our line set. Now, what is great about line set? Let's talk about line set real quick. All of our pieces of equipment from 2-ton to 5-ton air handler are going to use the same line set size, 3/8, 3/4, no 7/8, no inch and an eighth, nothing. It's 3/8, 3/4 for all tonnages. And you'll notice these caps right here on our flares. We simply depress this little black button here on our liquid line to let that nitrogen out. And then you're merely going to spin these caps off and start connecting your line set. So just depress this little black cap, let that nitrogen out, and those keepers will come right off. Okay, let's take a peek at the indoor coil section. We have our T1, which is return air sensor, room temp. T2 coil sensor. T2B coil sensor, T2A coil sensor. Here is our EEV and our mitigation control, our refrigerant leak detector right here at the bottom. Here's a exploded view of our 18 to 24K models, 30 and 36 right here. Beautiful M design coil for very hot, very efficient heating and cooling. And notice our refrigerant leak detector here at the bottom. Installation is super simple. I know this for a fact because I've built 5 of these training models. Once again, we are using one line set size, 3/8, 3/4 on the 24 to 60K models that Gensco does sell. Our minimum line set length is 12 feet. It is pre-charged to 25 feet in length. That's fantastic. And for those shorter line set lengths, maybe 12, 15, 17 feet, we do not need to take any of the refrigerant out. Just let it run, fire it up. Our total line set length is 164 feet. Total height difference is 82, and height change for an oil trap is 20 feet. Our minimum clearances when we're setting that outdoor unit. This is real nice, 4 inches from the wall of the house, 14 inches or more from any other obstructions on the sides, and 20 inches from the front. This keeps it nice and low profile for those zero clearance lot lines on the side of the house. And you will notice that we have a wall bracket, the MAS NDA wall bracket, so we don't have to use S and drive and bolt to the side of the people's house with S and drive. That doesn't look very nice. And I am under the impression that some municipalities and inspectors are saying no way to the S and drive mounted to the house and the equipment anymore. So check your local codes and municipalities for that update. This is all a part of the installation kit, the installation manual, the owner's manual. This is the pigtail that plugs right into the board for our 24-volt comm mode. If we're not going to run fully communicating, this just plugs right into the board. You'll see our RGYOW. We've got some zip ties right there, a little bit of extra insulation and some foam tape. And right here is our flare connections. We can flare directly to the equipment, or we can attach these flares with these stubs, 3/8, 3/4 stubs, and braze right onto the end of these. And they are flexible. You can basically bend them right into a 90 with your bare hands, and they won't kink. Indoor unit layout. let's pay close attention to our knockouts for our low volt and high volt wiring. I don't want you to alter the cabinet in any way. Please use the available knockouts from the factory. Do not alter the cabinet. This is our block and lock design with our very robust latches. I think some of you guys would think, well, is it sturdy? It is incredibly sturdy. When this unit is blocked and locked, it's going nowhere. It is extremely snug. Notice our condensate drains here. Upflow, downflow, low void, primary drains. Left, right, primary drains if you're going to lay this thing down. Downflow, horizontal left conversions. Evaporator coil can be easily converted for multi-position applications. Very simple. The only time that we're going to need to make some adjustments here is if we're going to go downflow and horizontal left. All we've got to do is remove T1 return air room sensor right here and put it up to here. We will reroute the sensing capability behind the frame to avoid pinching. We are going to use these little wire keepers right here. They are foam, anti-pinch, anti-strip. This is where our old positioning, if we're going to go in the downflow position, and then it reroutes up to the top right there. Control harness plugs are all right here. They are all one-way gated. When you take this unit apart or put it together, you cannot accidentally mix match plugs. They are all one-way gated. And we've got this beautiful foam keeper right here that just really beautifully snugs in all the wiring right there, keeps it all right and tight and clean. Here's a look at our electric heat installation. Here we've got what appears to be a 5 or a 10 kW heat kit. Very simple to install. Very simple to install. It's actually just going to remove 4 screws right here. First, you're going to have to remove this control board. It is 3 screws, 1 right there and 2 up at the top, and this control board just merely hangs right out of the way. Then we will go ahead and remove 4 screws from the backer plate and install our heat kit. Notice our heat kit plugs right here. It is all plug and play. Unplug the wiring harness right here. Let this control board slide out of the way, removing these 3 screws, 1 there, 1 there, 1 there. We will unplug the red and black wire plug that goes from the back plate and the fan control. Notice our flat plug right here ties into S1, S2, line 1, line 2, and ground right here. Do not throw this plug away. And I'm going to explain why, because we're going to use that as a jumper to power our indoor control board. There is a look at the control board out of the way. In this illustration, I actually removed the whole board. You will not need to. And notice that plug that plugs into the board and to the back plate. We're merely going to remove that, but we're not going to throw it away. We're going to use that in a later illustration. Remove the back plate. But what we're going to do is we're going to cut off this plug. Okay, we're going to remove these wires from these stake-on connections. We're going to remove those wires. We're going to cut that plug off. We're going to insert our strip heat right here. There is a look at the heat kit installed, and these are our back wall mounting bracket. Make sure it's true plumb and level. We are merely going to plug in the heat kit right there. We are going to set our breaker. 2 screws. This just snaps onto the bottom. Plug in the harness from the strip heat breaker, back of the fan control. And there is a look at our heat kit installed. Everything is nice. There's our breaker. There's our line 1, line 2, and ground. Some ground lugs right there. Reinstall the control box assembly. 3 screws go back in. Reconnect the control plugs. Remember, they're one-way gated. You can't accidentally mix match any plugs. They're one-way gated. And notice right here, that plug that I wanted you to cut the end off of is now our jumper that we're going to land on the load side of the breaker that powers our heat kit. And we are merely landing them on line 1, line 2, and ground. So that plug that we're not going to throw away, we just cut the flat plug off, strip it, add it to our breaker, and use those stake-on connectors that are already there to land power that powers our indoor control board. There is a look at the unit completely installed with the heat kit. As described, there's our jumper. Everything is plugged back in and ready to go. Make sure you install the breaker cover. Now we're done. That is the extent of the electric heat kit installation. Very, very, very simple and quick. It might take you, the first time you do it, it might take you 20 minutes or so. The second time you do one of these installations, it'll probably take you 10 minutes. Low boy applications, no more cutting, doing major surgery on a one-piece air handler. We are merely going to separate and install. Our convenient low boy installation for the height restrictions applications, we fit where other brands cannot. This is the only equipment with the block and lock design. Low boy application. Notice our supply and return plenum. Nice installation here. Somebody removed an old low boy oil furnace. Notice in this application, we have to go all front to front installations, no front to back installations. So basically, we want the front of the equipment always to be the same. No mix match, don't spin it a different way. Low boy base can. You can either build it yourself or have Columbia Manufacturing build you one. There are the dimensions if you need the cut sheet on the build. Columbia Manufacturing already has these in the computer ready to hit go, and we can manufacture you one in short order. Easy to service and easy to install indoor unit design. 3 integrated PCBs, main control board, data display board, 24-volt dip switches, wired controller and 7-segment display right on the front. Fan control board is located on the back of the assembly right here. High efficiency of manufacturing, easy maintenance, Molex plug wire connections. Everything's plug and play. Slide out fan assembly. We've got our spreader bar right here. Just remove 2 screws and disconnect the harnesses, and this fan slides right out. Loosen the wires and remove sensor wiring. Let's go over some wire connections. This is where I really want you guys to pay attention. On our line voltage wire, on our comm wires, we do not want you to use crimp connectors, straight wires. Just strip and insert into S1, S2. That is our comm wires. Notice an RNC here if we were going to go 24-volt control, which I highly don't recommend. Notice our comm wires are stripped. No stake-on connectors, no crimp connectors, just land RNC or S1, S2 right here. But we do want to use crimp connectors on our line voltage. Okay, don't try and squeeze number 8 or number 10 underneath these lugs. Let's use crimp connectors and get a really nice, snug, secure bond to the equipment. Here's our bidirectional communication or 24-volt control. You get to pick if you want to run a conventional thermostat, maybe an 8000, maybe a T6, or you can use the TLO4 stat as a 24-volt control. We highly recommend running fully communicating, just 2 wires from the TLO4 stat to the indoor unit and 2 wires to the outdoor unit. Let's take a peek at our indoor data board. Right here, we've got our 7-segment display, our low voltage connections. Right here is our HA and HB and our S1, S2. If we're going to go fully communicating, we land 2 wires right here, HAHB to HAHB on our TLO41 stat, and S1, S2. This is our communication out to our outdoor unit. But in the event that you want to run 24 volt, right here, here's your terminals. Just get your control screwdriver out and land your wires right there. There is our very easy to use plug and play 24-volt adapter and our dip switch settings, which we will go over later. Now, I will tell you that right out of the box, you do not need to set any dip switches, period. You do not need to set any dip switches. Now, if you wanted to turn this into a straight AC, we would set 1 dip switch. I don't know why you would want to turn a heat pump into a straight AC, but that's up to you. And by the way, this plug plugs in right here. Okay. This is our heater control, our indoor wire set, our dip switches, remote control, and our mitigation. This is where our refrigerant leak detector plugs in on CN8. Indoor main control board. Another look at it right here. SW8. We have a wet switch. If you want to add a wet switch in, we are going to land a wire here, do not use the middle, and we are going to remove the J1 jumper. And I have asked, is this Phoenix connector here removable? Yes, you can unplug it from the board, have it in your hand, do your wires, and plug it right back in. Let's take a look at our indoor fan board. This is the board that's on the back side of your data board that typically you can't see. CN12 is power to the transformer. CN11 is to the main board. CN50 to the fan motor. CN13 to the main board. Very basic, easy layout. Outdoor unit. We've already discussed this. We can go full 24 volt or communicating S1, S2. If we're going to go fully communicating, that is a 5-volt bias DC signal landed on S1, S2. And of course, our 24-volt connections are right here. RC, Y1, Y2, L for alarm. We're not going to need BWD. Another look at our TLO4 and 24-volt connections out at the outdoor unit. There's our S1, S2, if we're going to be fully communicating, and our 24-volt. And our 7-segment display right there. Dip switch and dial code functions. S1-1 is to be defined. S1-2, communication dial code, 24-volt communication only. SW1-3, strong cold and strong heat function. The heating, cooling, target pressure compensation value is valid. Always refer to your installation manual for your dip switch functions. Now, I will say in full communication mode, you will not have to, right out of the box, do nothing with any dip switches. SW1-4, enhanced defrosting. for those freezing fog locations, Eastern Washington, Eastern Oregon, Idaho, Montana. It is highly recommended that you switch SW1-4 to the on position for enhanced defrost. There's a look at our TLO41 thermostat. Notice our outdoor air temperature. Here's our mode. This is in auto mode. Our Wi-Fi is connected. Setup of the TLO41 stat is extremely intuitive. It's super simple. Right as we power up this equipment, it's just going to go through a flow of, do you want English or what language, country, time zone? Are we going to be in full communicating mode or 24 volt? You pick. You just make sure you check the right box for the control that you're using. And it can detect the availability operating modes automatically. Auto, heat, cool, emergency heat. Here we've got Celsius, Fahrenheit, our deadband settings. Auto mode, do we want single or dual? Our deadband settings. Also, we can set our max and min on heating and cooling. This is pretty important. I used to set up all thermostats to where the homeowner couldn't lower it down any lower than 66 degrees for obvious reasons. I don't want them to ice up the coil. We have an auxiliary heat function. We can either turn on or off the auxiliary heat. We can actually disable it from the TLO41 stat. Auxiliary heat activation. This is going to be an OTA that is coming at the end of August. That is, we can set that lockout. So if it's above 32, if it's above 31 degrees, we can lock out that strip heat. The aux heat lockout is coming shortly. Let's get into our wireless network. I told you that it does like to be connected to 2.4. Have the homeowner set it up. Password, it'll say connected. Then they can actually download the NetHome Plus app by simply scanning the QR code. And it'll let you know when it's connected and just hit finish. If we are not running Wi-Fi, we can set up the date and time independently. There's our cheeseburger, I call it, our menu button. Indoor temperature, humidity, set point, outdoor temp and time, and schedule status. Constant fan, we can turn it on or off. Auto, low, medium, high. This thermostat is very intuitive and gives you lots of things to set if needed. Comfort presets, home, away, sleep, pretty standard. Schedule, vacation mode. iCheck is very important. iCheck will give you an inside look at if this system is, everything is okay. This system goes into an iCheck feature that double checks itself. If it notices an issue, you can go to iCheck and it will actually tell you what the problem is. Maybe we're having a system communication error. Maybe there's you left a sensor unplugged. It will check itself out. And if we get all green check marks, you're ready to go. You can connect to the app, wireless network, temperature calibration. This is important. So on every thermostat, we're going to go ahead and install that onto the wall. We're going to get it fired up. And we want to make sure that that temperature that the thermostat is reading is accurate. So we're going to put our pen thermometer or a temp sensor on top of the thermostat, and we're going to walk away for 5 to 7 minutes and let those two just kind of see where it's at. If you need to make a temperature offset, you just merely go into temperature calibration and go up or down to match what your thermometer is reading. Date and time, location, temperature units, preferences, brightness, sound, available set point range, updates, remind you when you need to update. If we are connected to the NetHome Plus app and we are connected to Wi-Fi, it's going to do it automatically. And we can go to factory reset. We can restore this thing back to factory in the click of a button. Like I said, we can go to system check out. Oh, let's go to service real quick. Let's talk about this. To get into service, this is your universal passcode. So if you want to take a picture of it real quick, that is the universal password to get into the service mode. 159753. This lets you get into the advanced features of this TL041 stat. 159753. And if you forget that code or don't take a picture of it, and you grab your smartphone and look at your keypad, 159753 is in the form of an X. 159753. And that'll get you into the service settings, and you can go into the advanced features. 32-digit serial number, our software version, and software will be updated automatically if you are connected to Wi-Fi and the NetHome Plus app. It does have a built-in human proximity sensor. The screen will automatically light up when it detects someone approaching within 3 feet. 24-volt mode. Once again, it's very simple setup. English, United States, your time zone, and we are going to let it know we're going to go 24-volt communication. And then it's going to let you know what it finds as terminals that you have hooked up. If there is something wrong with the connection, it cannot go to the next step if the wiring is incorrect. It is letting you know that you have miswired it. Our OB settings, our reversing valve is energized in heating. Unit protection. What type of auxiliary heat are we using? Are we using electric heat? No electric heat? Are we dual fuel? Are we running a boiler? You pick what the auxiliary heat is. Now we're back to the main menu for our 24-volt control. We can go constant fan on or off, set our schedules, vacation, settings, and about. Once again, to get into the service mode, our password is 159753. Settings and scenarios. We're not going to spend a whole lot of time on this because this is a quick hitter. Automatic airflow adjustments on the TL041 stat in communication mode with a wide range of adjustable constant fan speeds, low, medium, high, turbo. Notice our constant CFM stays depending on static pressure. We can adjust. We can go into advanced settings with the remote control that does come with the equipment. It is for maintenance and engineering purposes only. And we can do very specific airflow adjustments if needed. But I can tell you right out of the box, since I built 5 of these, it is not needed. Here is a look at our wiring, whether we're going 24-volt or fully communicating. And I will tell you that we recommend fully communicating all the time. It allows this system to function and run the way it is designed with the maximum amount of performance. Factory default, all the dip switches are off. The power to the indoor unit does need to be off when making dip switch adjustments. If you make dip switch adjustments while the system is powered up, you will need to power down that equipment and power it back up. Since we are talking about powering up and powering down equipment, when you install this equipment, indoor and outdoor, it is highly recommended that you power up the outdoor unit first and the indoor unit second. Dip switch settings, control scenarios, S1, S2, 2 wires to the outdoor unit, HAHB to HAHB on the indoor wired controller, the TL04 stat, and you do not have to set any dip switches, but we can set a dip switch to auto recognize. Scenario 3, 24-volt communication. Guys, this is no different than anything you've already installed. We've been installing 24-volt controls for 55, 60 years now. We've got RC, G, W, Y, O. Our reversing valve is energized in the heat position, not the cooling position. I highly recommend that you use fully communicating. 2 wires to the indoor, 2 wires to the outdoor. In the event that you wanted to use a different stat, make sure that we are able to set cycles per hour to 1 on the compressor. And look at this scenario here. We've got a 24-volt stat connected 24-volt to the indoor unit and only 2 wires going out to the outdoor unit. In that scenario, we are going to turn on dip switch SW1 to auto recognize. Here's a look at our low voltage wiring to the air handler via 24-volt stat. Everything looks pretty normal there. Remember, I was recommending that you use a 3 heat 2 cool thermostat, and I want you to set the compressor cycles to 1. If we were to set cycles per hour to 3 and 4, it's probably going to become an issue in defrost. This equipment likes longer run times at a lower modulation. The L terminal is an optional terminal for alarm, which technically we don't even use anymore. And the reversing valve energizes in the heat mode. Air handler unit heat function guide. Indoor unit SW1 factory setting is off, has automatic control scenario recognition. The system will know it is wired control signal versus 24-volt signal with dip switch SW1 in the on position auto recognize. Make sure you look into your install manual for the exact dip switch functions and settings. Like I said, right out of the box, you don't need to set any at all. We're not going to spend a whole lot of time on dip switches. There's SW4-4, control scenario 1-3, default on. For single stage supplemental heat, W1, W2 are connected. For dual stage supplemental heat, W1, W2 are controlled independently with SW4-4, either on or off. "24-volt thermostat running identification." This is all going to display on your indoor 7-segment display. This is the scenario that we prefer you guys using 2-wire control. HAHB. And by the way, guys, let's stay polarity sensitive. Whatever color we have landed on HA on the indoor unit, let's land on HA on the wired controller. That goes throughout the whole system. Let's stay color sensitive. Let's stay polarity sensitive and not have any mistakes. I had a call yesterday where the installer could not get the outdoor unit to run to save his life. Well, on S1 and S2 on the indoor unit to S1, S2 at the outdoor unit, he, for whatever reason, had green and white hooked up to S1, S2 on the indoor, but black and red to the outdoor unit. Well, there's no way that that unit's going to come on when there's no communication. Make sure you're using the right wires, stay color coded and polarity sensitive. There's a look at our wiring diagram. If you want to take a quick picture of it, it's pretty simple. HAHB from the stat to HAHB on the board, S1, S2 on the indoor board to S1, S2 on the outdoor board. There's another look at it. SW2-1, control scenario 2, which we are talking about right now, fully communicating. Temperature differential to activate first stage auxiliary heat. The gap of T1 and TS wire controlled demand with heat pump plus electric heat work together. 2 degrees is dip switch SW2-1 in the on position. Default, right out of the gate, dip switch in the off position is a 4-degree deadband. Compressor and auxiliary heat outdoor ambient lockout. We can lock out the compressor at a certain temperature. I don't know why we would let this high-performing equipment run. More dip switch settings. It does seem like there's a lot of dip switch settings, but guys, at the end of the day, there is not. You're merely going to set dip switches as per how you want to set it up, but out of the gate, you really don't need to set any. If we were going to set our temperature differential, SW3-3 control scenario 2, which is fully communicating. Default is 6 degrees. Dip switch SW3-3 in the on position is 4. Operation. You will notice the difference between an inverter and a non-inverter. Basically, we have a choppy sine wave and a smoother sine wave. And basically what we are doing is controlling it better. Less stop and starts. We want longer run times at a lower modulation, which is going to give us better energy efficiency at the end of the day. Less amp draw, longer run times, low modulation, period. Actually, this equipment is kind of designed to run 12 to 14 hours a day at a very low modulation. Think mini split, but in a unitary application. Our sensors, as described earlier in the presentation, T1 is your indoor room temperature. It's basically sensing the return air temperature. T2, T2A, T2B, evaporator, indoor heat exchanger temperature. It is measuring the temperature at all times. T3 is a condenser, outdoor heat exchanger temperature. T4, outdoor ambient temperature. And by the way, since we're going to talk about the outdoor ambient temperature sensor, if the outdoor temperature is between 79 and 83 degrees and you give this unit a call for heating, it will not like that, and it will block the heating call to the outdoor unit. It will not energize that reversing valve to protect itself on going off on high head pressure in 3 to 5 seconds. And T5 is our compressor discharge temperature. Test operation. To test operation, all we really need to do is make sure that all of our system checks are done. We've got we did do a pressure test. We did pull a nice tight vacuum. We did dump the charge. We did add for additional line set length. Our power is correct. Our power is correct in the indoor. Our thermostat's lit up. And now we're just going to go ahead and give it a call for cooling. Drainage test, we're going to make sure that our condensate drains are flowing correctly. We do have a P-trap. I know that some installations I go to on site visits, there is no P-trap. Always, always, always put a P-trap on your installations. Cooling mode, compressor run frequency will be recalculated in certain periods time according to current frequency. So basically, this thing is going to run and make adjustments as needed based on time and temperature. Low ambient cooling, when T4, 59 degrees, and compressor is running, the unit will enter low ambient cooling operation and the outdoor fan will choose what speed it wants to run at to build head pressure for low ambient cooling, which in this application with this equipment, we can choose to turn that heat pump into a straight AC like discussed. Heating mode, compressor start frequency control. In heating mode, fan speed, 80 to 100%, auto, turbo, and high. 60 to 79% is medium, 40 to 59% low. Smart humidity control built in with our TLO4 stat. Outdoor fan control, the outdoor unit will be run at different fan speeds according to the outdoor ambient temperature and compressor frequency. Defrost mode, the unit enters defrost mode according to the temperature value of the condenser temperature and outdoor ambient temperature, as well as the compressor run time. It will auto adjust as needed. If it needs a longer run time, it will. It's going to start with a clean coil every time. Electric heat operation with the TLO4 stat. Reach the temperature difference to start electric heat first time in patent. So if on a call for aux heat, the control will turn the compressor off for 10 seconds to prevent a patent violation. I'm not sure why that's a patent violation, but the compressor will turn off for 10 seconds and will not run with the strip heat. The compressor will drop out for 10 seconds. Let's talk about the A coil installation if we're going to be doing a dual fuel application. It's a standard cased coil with mitigation controls built in. There we have our gas furnace. Our A coil obviously is an upflow application because that coil is on the top. Up to 16 SEER2, EER2 up to 10.7, HSPF up to 10, and COP at 5 degrees, 1.9. The coil is multi-positional, downflow, horizontal left, horizontal right, upflow, dual fuel controls built in. The mitigation control is built in, works with any 24-volt gas furnace, single stage or two stage, PSC or CTM variable speed indoor blower motor, and can use 24-volt or our TLO4 Midea communicating stat dehumidification capability. Let's take a peek at it real quick. We have an upflow application here. Here we have our wired controller. This is going to be our TLO4. Here's our mitigation control board that you are going to wire and mount. We are going to take our T2, our T1 sensor and insert it into the return side of the ductwork. Above the filter, before the filter, we're going to install that T1 sensor to sense the true return air. This is just like every other coil installation, guys. Let's talk about our widths. We got 17.5 by 21 by 18. Nice low profile for that 2-ton. The 2.5 to 3-ton, 17.5, 23 tall and 21 wide. Notice that our 4 and 5-ton model, 27 by 21 by 21. Our 5-ton, 4 and 5-ton model, the MAAHE 60, 24 by 28. There's a look at our mitigation control board that you are going to mount somewhere very close to the furnace installation. It's got screws. It's got sensors. It's got a sensor for T1 that is 5 meters long. It's an extension cable, but if you don't need a full 5 meters, 15 feet, we've got one that is roughly 4 feet long to install into the return air. Our static pressure drops and CFM. All of this information is in the install manual. Airflow must be set between 350, 400 CFM on that gas furnace, guys. Do not exceed 350. In your downflow application, we could have liftoff, condensate liftoff of the coil. Outdoor unit can be changed to AC only. If we set SW1-3 on the indoor board, we can turn it into a straight AC, and that also goes for the air handler. And T1 sensor, return air sensor, must be installed into the return air. And T2 is pre-installed in the coil. So the only sensor you will need to install is the T1 sensor into the return air. Let's take a look at that mitigation control board real quick. Here's our 24-volt controls. Here's our S1, S2. If we're going to be fully communicating, this goes out to the outdoor unit. Here's our mitigation controls. This goes to our refrigerant leak detector. And that refrigerant leak detector must be plugged into CN8, the black plug, not the red plug. Must be plugged into the black plug, okay? Here's our T1 sensor, our return air sensor. Must be plugged into the blue plug. The T1 sensor does have a blue plug on the end of it. It is color-coded. Control signals to the furnace are 24-volt thermostat connections and 24-volt power. All of this is in your installation manual. Here is another look at our terminals, RC, W1, W2, OB, Y1, Y2, OW2, OW1, This is where we're connecting our thermostat at and our T2 sensor and S1, S2. This has to do with the refrigerant leak detector. We must be plugged into the black port, and SW5 must be in the off position. Our dip switch selections. Leak detection. In the event of a leak, the sensor is going to detect that leak. The buzzer will sound for 5 minutes. Fan motor will run at max speed, and an error code of EHC1 will be displayed on the 7-segment display. The compressor will not run, and if the LFL drops below 7% for 6 minutes, it will restart normal operation. If not, you will be in a hard lockout. If a leak is detected, the process repeats hard lockout on third detection. Scenario number 1, 24-volt thermostat, S1, S2. So basically, we're going to be running a 24-volt conventional thermostat and S1, S2 to the outdoor unit. Here we have a Prestige 8000 coil outdoor unit. We are merely going to use our 24-volt controls from the thermostat to the indoor board and S1, S2 to the outdoor unit. There is a look at our low voltage wiring and the standard dip switch settings that we have already discussed. Notice we were talking about the anti-cold blow option. When we go into defrost, we are not pumping this house full of cold air. Therefore, technically, we don't even need stripping in the event if you're going to be running an air handler. Control scenarios, if we want to lock out that outdoor unit based on a certain outdoor temp, we can do that and just run fossil fuel. Same dip switch settings we've already been talking about. SW4-1, control scenario 1 and 3. Default is on. Default is for single stage supplemental heat. W1 and W2 are connected. And for dual stage supplemental heat, W1 and W2 are controlled independently. That would be in the off position. When we are running an aftermarket stat, T6, 8000, what have you, we must set the compressor cycles to 1 per hour. Defrost will be a problem if left at 3 cycles per hour or more. We do go on a time-based modulation. System sets at TS-based and demand at T1 temp. System will adjust TS based on time. More scenarios in the display on your indoor board. Control scenario 2, HAHB and S1, S2. This is fully communicating. We've got our TLO4 stat, our cased coil with our mitigation control board, and our outdoor unit. We are merely running S1, S2 from the indoor to the mitigation control board, and HAHB stat to indoor, S1, S2 to the outdoor. If you want to check voltage at your thermostat, the indoor unit should be putting out 20 volts DC. So let's say you have everything hooked up, powered up, and your thermostat is not lighting up. Your TLO4 stat is not lighting up. Let's grab our meter and put it on volts DC and go to HAHB. Do we have 20 volts DC there? Now, in the event that we are running dual fuel, notice we have added something to the scenario here. We have a Mars 9293 relay. So we have HAHB going to the mitigation control board. So we've got our HA and HB going to our mitigation control board. We've got our furnace and our 24-volt connections landed to the mitigation control board. But we are going to use this 9293 relay to ensure that the indoor blower comes on and a call for cooling. That is going to be changing in the near future, not just yet on this mitigation control board. They are going to go to a built-in relay to ensure that the blower does come on in a call for cooling. Right now, if we're going to go dual fuel and we're going to run this exact control scenario, we will need that relay in place. A coil dip switch scenario guides, it's the standard, exactly what we've been talking about. Refer to your install manual for proper dip switch settings. SW2-1-2, control scenario. Number 2, temperature differential to activate first stage furnace heating for heat pump furnace mode, and no, the furnace and the heat pump will never run at the same time. More lockout scenarios for the A coil dip switch scenario guide. SW3-3, control scenario 2, temperature differential to activate second stage furnace heating for furnace only or heat pump furnace mode. SW5, remember, SW5 is for our refrigerant leak detectors. Remember, on this board, there is 2 spots, a black and a red. If SW5 is in the on position, you will get an error code. Make sure that your refrigerant leak detector is plugged into CN8, and it is the black plug on the board. More control scenarios, depending on your control scenario, whether you're 24 volt and running S1, S2 out to the outdoor unit, so on and so forth, refer to your install manual. Dip switch settings are not 100% necessary. We've already talked about SW3-3, temperature control. We're not going to get into a whole bunch of time here, but heat pump and furnace means that the system will run whichever system the system allows. Furnace and heat pump will never run at the same time, even in defrost. When the outdoor unit shuts down, the fan continues to run for about 20 seconds. And by the way, when that unit shuts down in a call for cooling or heating, it does have a coil clean feature, which will make the condenser fan motor run backwards after the call is terminated, and it will run for about 30 to 45 seconds and blow any cottonwood or anything off the coil, which is a great feature. These are pressure and temperature and fan curves. Refrigerant leak detector scenarios, we've already discussed it. If in the event we go into a mitigation event, we're going to kill the outdoor unit, we're going to bring on the fan and mitigate the air. There's a look at some error codes that are common in the event of an error pops up. EHC1, leak detected. EHC2, leak detected, sensor out of range. So EHC2 could be that we are in a mitigation event, or that the sensor is out of range. Now, if in the event that you get an FHCC, sensor malfunction, you will need to double check to make sure that you have the sensor plugged into the black CN8 port. If it is plugged into the red port, it's not going to recognize it, and it'll give you the FHCC. It doesn't mean that the sensor is bad. It just means that there is a malfunction on it finding itself. And make sure that SW5 is in the off position. So SW5 in the off position, it's a little red single dip switch. And make sure your mitigation, your refrigerant leak detector is plugged into the black CN8 port. We already went through the refrigerant detection system, leak detected, outdoor unit shuts down, fan kicks on, so on and so forth. If a leak is detected, the process repeats, hard lockout on third detection. Troubleshooting, there are lots of error codes that are on the inside panel of the air handler and in the cased coil. So on the 7-segment display, look at your error codes and start chasing down what the error code pertains to. All right, questions. Thank you for joining us on this quick hitter. We greatly appreciate you sitting in on this and getting some learning in. Don't hesitate to reach out to your branches for upcoming trainings on the Midea. Very, very impressive piece of equipment. Somebody asked 3/8 3/4 line set, no alternatives. No, we're going to stay 3/8 3/4. Any suggestions for vacuuming down? We've had issues. not sure exactly what issues you're having, but understand we have EEVs on this equipment. And if you're using an air handler, let's go ahead and power up that air handler, and that EEV is going to drive open to 20%. That's going to allow you to do your nitrogen sweep. And by the way, guys, a couple things regarding line sets and installation. You do not need to install a liquid line filter dryer, period. We have strainers built in. Make sure that you do a nitrogen sweep. If not, you're going to clog up some strainers. You're going to clog up the EEV. You're going to have a non-functional system that is polluted. Outdoor unit is 240 volt only? Yes. Zoning applications. We do have some companies locally that have put the system on Honeywell zoning. What if the 2.4 network isn't available? Well, we can try 5. Is this made by Trane? No, it's made by Midea. Do we need to have power on 24 hours before running the compressor for the first time? No, but I'll tell you this much. If it's 5 degrees or 15 degrees outside, you might want to power up that unit for a bit. Is the indoor coil aluminum? Yes, it is aluminum coil. Any suggestions for low static situations? Had low splits in this situation. No fully communicating on zoning yet. Zoning will be done in a 24 volt application only at this time. I have not come across any low delta T's in low static applications. Can we add room temperature sensors with the Midea stat? No, not at this time, but I have been in some discussions, a couple meetings with Midea, and that is definitely on their radar to get wireless sensors. It is something they're actively working on. And yes, you're only going to be charging this system per your line set adder. We're not going by superheat and subcooling. This system takes care of everything for you. It is so smart that it's going to make the adjustments as needed. So you're going to see your superheat and subcool kind of walk around because it's going to do what it wants to do. And that's not something I made up. That is straight from the factory. Summer fan switch for dual fuel, no continuous fan. Yes, you can do continuous fan. Understand we've got to have that relay installed. What is the sound level of the outdoor unit? I was on a site where one was installed. It was a 2-ton unit. It was rated for up to 59 decibels, but we were actually recording about 52 to 53. The equipment is extremely quiet outdoor, extremely quiet. You're going to see somewhere between 54, 56 decibels. Okay, I don't think there's any other questions. Don't hesitate to reach out to your branch for upcoming trainings on anything, especially Midea. Don't hesitate to reach out and call tech support. And if you have any questions, we are here for you Monday through Friday, 7:30 to 4:30. That phone number for tech support is 253-620-8282. And we look forward to talking to you in the future. I appreciate you guys sitting on this quick hitter. Training is very, very, very important. It makes us better technicians and better installers. So without further ado, I appreciate it, guys, and look forward to talking to you in the future. Thank you.